For more math help, visit us online at mathfolio.com for math resources for middle school and high school. Today's math tutorial will be connected with 7th grade mathematics. This is a final test prep review, and also it might be useful for summer school as well. This math worksheet can be, in fact, it's a math packet, can be downloaded at mathfolio.com/7/final review. There are 40 questions, and this video series will be broken down into 4 parts. So the best advice I can give is to download the review sheet, mathfolio.com/7/final review, print it out and attempt the questions yourself, and then come back and you'll be able to grade your sheet, and also you'll be able to find help with the questions that you need help on. Okay, so let's get to it. Here's question number 1, and in this question we're told that for the first 8 months after Ellen opened her cupcake store, she made a profit of $220. So straight away, when you are answering questions like this, often a lot of information is going to be thrown at you. So things like her name, whether it's a cupcake store, these types of things aren't all that important. But profit of $220 per month is important. 8 months is important. And so even this first sentence tells us that she's earning plus $220. This is a profit, so she's earning plus $220 for 8 months. So I'm just going to jot this down right now. So that's the first bit of information. We're then told that during the next 4 months, so it says 4 months right here, during the next 4 months, she made a loss of $150 per month. So again, is it plus, is it minus? Well, this is minus a negative $150 per month for the next 4 months. So it's definitely important that we include the signs, whether it's plus 220 or negative, a positive 220 or a negative 150. Definitely very important. And so the final question, which is also very important, is what was her average monthly profit for the first 12 months? So often when we're just asked for the average, we are really asked specifically for the mean average. So the mean is going to be the sum of each of the months' profit or loss divided by the total number of months. Well, we know that we've got 12 months. So what we really need to do is add up all of the amounts. Well, she's making 220, positive 220, plus a positive 220, plus a positive 220. And before you know it, I'm actually going to run out of room here if I keep going. But we know that this is going to be her profit for the first 8 months. So we have to add this up 8 times. And then we're going to start adding negative numbers. We're going to add negative 150 plus negative 150 plus negative 150. And we're going to do this 4 times because she did it for 4 times. And then after we've done all of this, we are going to divide by the number of months, which is 12. Now, really, I should have shown you this plus 228 times, but I'm not all that concerned with that because the shortcut here is to realize that if we're adding something 8 times, it's the same as multiplying. So in this case, our mean, we can calculate the mean by doing 8 times by 220. So that's the equivalent of me adding 228 times, and then we're going to add to it 4 times by negative 150. And that's the equivalent of me adding negative 150 4 times. Then when we've done that, we are going to divide by 12 because there's 12 months. So I'm going to break out and do a little bit of work over here. If I'm doing 220 times by the 8. So if you had a calculator, obviously you could use that if the test or even in real life, you wouldn't do this if you had a calculator next to you. 8 times 0, 0. 8 times 2 is 16, carry the 1. 8 times 2 is 16, carry the 1 is 17. So the first piece I get 1760. For the next bit, I've got to do negative 150 times by 4. So first of all, let's just forget that negative for now. 4 zeros are 0, 4 fives are 20. So I put my 0, carry the 2. 4 1s are 4, plus the 2 is 6. Now, 600 is my answer for 4 times 150, but now we've got to rely on our knowledge of positive numbers times the negative numbers. So a positive multiplied by a negative is a negative. The negative stays. So in fact, our equation on the right becomes, this equals 1760, and then I'm going to add negative 600. So in this case, I'm going to have to deal in a second with this plus a negative. So let's deal with that now. When we are adding a negative number, which we're doing here, it's the same as subtract. So really, I'm going to use my workspace over here, 1760 subtract 600. If I subtract this, 0 minus 0 is 0, 6 minus 0 is 6, 7 minus 6 is 1, and then we keep this 1. So really, we've simplified this mean even more right now. So the mean equals 1160 divided by 12. And so at this point, we can do things like, we could simplify. So we could divide by 2 and divide by 2. We could do long division. So we could try and figure out how many 12s go into 1160, or we could use a calculator. So for some of the other questions in this series, in this review series, I'm going to use my calculator. For this case, I'm going to go through long division. It looks like it's doable. So let's remember the first number we say, which in this case is 1160. And let's remember this fraction here, 1160 over 12, fractions are division. So the first number we say is 1160 divided by 12. The first number goes in the house. So 1160 is inside, 12 is outside. Now 12 into 1, 0. 12 into 11 doesn't quite go. 12 into 116. So definitely goes. 116 is a big number. Now, in order to understand this, I like to think, well, what's an easy big number that 12 could go into? Well, 12 could go into 120. Now, 116 is almost there, but it's not quite. So instead of 12 going into 120 10 times, 12 must go into 116 9 times. So 9 12s, well, 9 10s is 90, 9 2s is 18. So 90 plus 18 gives us 108. So when we go back, we put 108, subtract, we get left with an 8, and bring down this 0. So now we've got 80. Well, we could think, well, 7 12s, 7 times 12 gives me an 84. So let's think, that's too big. So instead of 7, maybe it's 6. So if I put a 6 there, 6 12s, 6 10s is 60, 6 2s are 12, so that makes 72. 72. And when I subtract 80 minus 72, I get an 8 left over again. So as I just had an 8, this pattern is going to keep leaving me with 80s, and so I'm going to get 12 into these 80s that keep repeating is going to always be 6. So I could leave my answer as 96.6 recurring. Now, because this is money, and let's just think what we're trying to work out. We're trying to find out her mean average monthly profit for the first 12 months of business. Well, so far we've got this as equaling 96.6 recurring, and because it's profit, it's really dollars. But because this is money, it just makes sense to leave the tenths place and the hundredths place, because we're not going to pay somebody back $0.6666666. We're just not going to do it. Money is always to 2 decimal places. And so in this case, we could write that the answer is 96.60. And you might think 66, but because this 6 goes on forever, we have to round the 6 that goes on up to a 7. And so this would be our answer for question number 1. Okay, question number 2. Another tricky question. Let's read this. So it says, what is the result when, and then this awkward looking quantity. So it could have just said, what is the result when 5 is subtracted from 6, but it doesn't. It says, what is the result when this quantity, which is 1 1/3 x minus 2.5, when this quantity is subtracted from this other quantity. Now, if we were to say something, what is the result when 5 is subtracted from 6, the math would be 6 minus 5. Notice what we did. What is the result when 5 is subtracted from? Now, from is the very important word here because it switched our 5 and 6 around. So if it said, what is the result when A is subtracted from B? Again, if it says the word from, we would switch it around. We would do B minus A. So in this case, what is the result when 1 1/3 x minus 2.5 is subtracted from 6 4/5 x minus 5 3/4? We have to switch this order. So it becomes 6 4/5 x minus 5 3/4, and I'm being very careful to copy this down correctly, minus, now we go back to our 1 1/3 x minus 2.5. And also I'm noticing we got decimals, 2.5, and we've got fractions as well. So that's going to be interesting a little later. So now we've crossed this first hurdle. That was one of the big areas that a lot of people are going to make mistakes. Now it's important to understand what effect this minus the entire quantity in these second parentheses, what effect that has. Now if we were just minusing 1 1/3, we could just write minus 1 1/3, or even if it's 1 1/3 x, we could just write minus 1 1/3 x. But it's not. This entire quantity in the second set of parentheses says also 1 1/3 x minus 2.5. So one great way that could help you understand some of the problems that students have with this is to see this minus out here and how it must distribute to the things inside the terms inside the second set of parentheses. So one way of doing this is to think that instead of just saying minus, it's really minus one of these quantities. So we're minusing one set of this parentheses. Now, because we've got this invisible 1 outside, it has to distribute. So we're going to send these rockets from the number outside, which is now looking like a -1, we're going to distribute it inside. So watch what happens. And notice we're only looking at the second set right now, the second set of parentheses. We've got minus -1 times 1 1/3 x. That becomes minus 1 1/3 x. Now, when we distribute the -1 to the minus 2.5, it actually becomes plus 2.5. Okay, so we removed the parentheses, and we've done that by distributing this negative to each of them, which makes sense. If we were just minusing everything in these parentheses from the first set, we would do minus this, and then we have to minus a negative. So when we're minusing this negative in the second part, we're really adding it. So that's why it becomes plus 2.5. I'm going to bring down the rest, which is 6 4/5 x minus 5 3/4. And so right now, this is what we need to calculate. So I'm going to switch some colors up because now we need to combine like terms. So as we're looking at this, some of them have x's and some of them don't. These ones that say x, so we've got 6 4/5 x, and I'm going to group that minus in with this. We need to subtract 1 1/3 x. So because they're both x's, and they both have the same exponent, the same power of x, it's an invisible 1, we can group these. So as I always say, this is like animals in a zoo. You're only going to put the same types of animals together in the zoo. So here our animal is x, and we've got 6 4/5 x, and at some point we're going to subtract 1 1/3 x from it. So that's going to deal with this bit, and it's going to deal with this bit. Now the next step that we're going to do is we are going to look at the numbers. So the second animal that we've got is just numbers, no variables. We've got 2.5, and I'm going to group the minus in here, 5 and 3/4. So the rest of this is going to be plus 2.5. Now, I could write 2.5 as 2.5. For now, I'm just going to leave it like that, but at some point I'm going to have to think about decimals and fractions. And this is going to be minus 5 and 3/4. So, because we now have mixed numbers, there is a few things that we can do. We could just get rid of this mixed number, this minus 1 and 1/3. We could turn it into minus 1/3 x by dealing with this 1 and taking it away from the 6 over there. We could do that. But what I'm going to do might kind of seem like the long way round, but I'm just going to get common denominators with these numbers. So I'm going to do my C move. So you'll notice that these blue arrows kind of make a C. And in order to do this, we're going to do 5 times 6. So that's multiply. And then we're going to add the 4. And this gives us our new numerator. So 5 times 6 is 30, plus 4 becomes 34. And we keep the denominator, which is 5. So that's 34 over 5x minus, again, the C move. 3 times 1 is 3, plus 1 is 4, minus 4 over 3x. And I still need to work out these common denominators in a second. But then let's just finish this. We're going to add. Now, let's turn both of these into decimals. So we're adding 2.5 minus, now 5 and 3/4. Well, 3/4 is 75 cents. So 3/4 is going to be 0.75. So you could just do 3 divided by 4 to figure that out as well. Okay, so I'm going to split this page a little. I'm going to grab, let me grab a line tool here. And I'm just going to split this page, and then I'm going to show some other work on the other side. So 34 all over 5x, and we were subtracting 4 over 3x. So just let's look at these first terms. How are we going to do this? Well, this is the same if we're looking at common denominators. I'm just getting my fraction lines ready. Instead of 5 and 3, the least common denominator that we can use is 15. So this 3 turns into the 15 by multiplying by 3. So let's do the same to the top. Let's times that by 3 as well. So 34 times 3, well, 3 30s are 90, 3 4s are 12, so 90 plus 12 is 102. And let's not forget our x as well. Now, I'm going to change color just so this is a little clearer, to go from 4/3 x to also keep 15. What we need to, we multiplied by 5. So we've got to do the same to the top. 4 times by 5. So this gives us 20. And the result, let's not forget the x as well. The result of this, 102 minus 20, is going to give us 82 all over 15x. And this can be brought back from an improper fraction to a mixed number. 15 goes into 82. Well, we could count up in 15s. I just know that 15 times 5 is 75, so that brings us close. So it's 5. 5 15s is 75. The remainder is 7. So it becomes 5 and 7/15 x. I know this question's a lot of work, but it's showing many of the things that we've learned in class and in previous math tutorials as well. So this piece right here is this bit, the bottom left, is the bottom left bit worked out. We still need to work out this bottom right bit. You'll see I'm boxing this up in red right now. Now, because this is a smaller number, 2.5, and we're subtracting a bigger number, it's going to give us a negative number. So with 2.5, let me do my 0.5 minus 5.75, I like to always think of this on a number line. So let's just put 0 in the middle. So our starting number is 2.5. That's a point, not 205. And we are subtracting 5.75. So really we want to go all the way past 0 to some number on the other side. This is subtract 5.75. But we can't necessarily do this very easily in our heads. But if we think how far did we go to get from 2.5 to 0, we know that we just took the full amount. We took 2.5 away. So when thinking about what else do we still need to subtract, it's really the difference between 5.75 and 2.5. So one little trick that we can do is never forget that our answer is going to be negative, but switch the numbers. So we can do 5.75 subtract 2.5. So notice I'm lining up the decimals. I'm going to insert this invisible 0, which we didn't see. 5 minus 0 is 5. 7 minus 5 is 2. 5. Put the point there as well. 5 minus 2 is 3. So we get 3.25. So really, we still have to subtract another 3.25 from 0. And that's going to give us a final answer of negative 3.25. So now we need to put both pieces together. We've got to bring down this here into our final answer, and we've got to bring down the answer here into our final answer. And so we can just write this straight. It's 5. Just write that a little clearer. 5 and 7/15 x minus 3.25. And you know, we have this as a fraction here, and we have this as a decimal. That's okay. If we wanted to change this to a fraction as well, it would be 3 1/4, because 0.25 is 1/4. But this is our answer to question number 2. Question number 3. Matthew bought a new skateboard from Kelly's Skateboard Shack. It was on sale for 30% off. So that's my first piece of very useful information. It was 30% off. So again, just because we're using maths, we've always got to start writing down the important information. There's too many words here. And also, as we get to know the structure of certain types of problems, it can help us prepare. So he bought a new skateboard, 30% off. And he paid $56. It wants to know the original price before the discount. So one way of doing this is to think, okay, what's the original price? Let's call it X. So X was the original price. It was on sale for 30% off. So we deducted 30% of the price, which was X. So we subtracted 30% of X. And then he paid $56 for it. So really, if he subtracted 30%, it means that he paid 70%, right? It means that he paid 70% of the value of whatever it was to begin with, and that came out to $56. So at this point, there's a few different methods to try and find it. One method, let me do methods in different colors. One method is to write 70% as a decimal, which is 0.7, because this would be 0.70. Remember, we would just divide a percent by 100 to get a decimal, so the point would go in front and we would drop the percent. So 70% is 0.7 times x, which we write as 0.7x, and this equals 56. So this is now a one-step equation. Just remember how we got here. We deduced that because he took off 30%, he was really paying for 70% of the original price. Instead of paying for 100% of the price, he paid for 70%. There was a 30% discount. So that's 0.7 times x. To get x on its own, which is the original price, we would divide by this coefficient, the 0.7. Got to do the same to both sides. So in this case, our 0.7s would cancel. We'd be left with x equals, and again, we could do the long division here, put 56 inside the house and put the 0.7 outside. In fact, let's do it. We're going to do it. So 56 would go inside the house. It's the first number you say. 0.7 0.7 goes outside. Now, we don't like decimals outside the house, so we got to fix this. We send the point over to the right one. That makes it 7. Now, we're only allowed to do that if we do the same inside. So instead of 56 and nothing else, the point, which would be after, moves 1 to the right, so it becomes 560. So really, this move is times 10 times 10, and we're allowed to do that. As long as we do it to both things, it's fine. So 7 into 5 is 0. 7 into 56, well, that's 8 times. 8 sevens are 56. Subtract, we get 0, but we don't leave it like this. Because we have this extra 0, it moves up. It becomes 80. So our answer is 80, but because the question says what was the original price, we're dealing with money. So we should say $80, and also we should go and say, we should write it out. We should say the original price, there's a little bit of a lag, the original price was $80. And so this is one method that we just solved it in red. Another method to do this would be to look at a box method. So the box method is actually where you kind of draw a box, and it works out very similar math, but this works for all types of percent questions. So what we can do is we can think of the first one being part, the second one underneath being whole, the next one being percent, and then this one is always 100. And so let's start to plug in the part that we're looking for. Are we looking for the part, or are we looking for the whole? Well, we're actually looking for the whole price, right? So the whole would go in here. Let me write this in, let me stick with the green. So the whole price is X. He paid a part of that, which was $56. The percent that he paid, well, remember, if he took 30% off, it means that he paid for 70%. So it's 70. And now we've got this. In actual fact, this is a proportion. So I'm going to switch to orange for a second. This is a proportion because we got 56 over X. Let's just write that, 56 over X equals, so I'm going to put my equals in here, 70 over 100. So this is 70 over 100. So notice what happens here. And just remember how we set up this box in green. We put the part is always the top left, the whole is the bottom left, the percent is the top right, and 100 always goes in that bottom right box. So now if we cross multiply, we've got X times 70, which gives us 70X. We've then got 56 times by 100, which, because we're multiplying by 100, it has 2 zeros. They just get put on the end, 5600. Now, to get X on its own, we would divide by the coefficient. In this case, it's 70. Do the same to both sides. And so the 70s cancel, and we're left with X equals 50. It's not coming through. 5600 divided by 70. Now, one of the first things that we can do here, if I can get the 0 to right, one of the first things that we can do here is we can cancel a 0 for a 0. That's the same as just dividing top and bottom by 10. So it's really 560 divided by 7. And if you notice, it's the same math that we did over here. 560 divided by 7, and we would get our answer of $80. So here's two methods. There's many more methods. It's really, if you have a calculator available, maybe one's going to seem more attractive. If you like this box method, this can help you for many, many different types of percent problem as well. Okay, that was question number 3. Question number 4. Okay, so this problem has many layers in it. Okay, so it's a long story. So let's see, a clothing store manager arrives at a price. That just means he decides on the price to sell. he arrives at the price to sell an item for by taking the price the store paid for the item. Okay, so by taking the price the store paid for the item, let's just call this X. So store paid. So the store has to buy these items that they sell. That's the first thing. We need to understand how that business works. So let's just say that store paid X. But then they add 50% of that price on top of what they paid. And so that's for them to sell it. So their sales price, the tag price that they have, is the original price plus 50% of X, so plus 50% of what they paid. And the manager also rewards her sales assistants by giving them 10% commission. So the commission is 10% of their sales, so 10% of the sales price. Okay, so let's switch color. We're going to move to red. The final question here, very important. You've got to understand this. How much commission would a sales assistant earn on a product the store originally bought for $20? So if this was $20, we've first got to think, how much was the sales price? Well, the sales price would be 20, which is our X, plus 50% of X. Okay, so this would give you the sales price. One way to think of this is this is your X, and this is 50% of X. Well, 50% of X as a decimal is 0.5X. So because we're adding 50%, this is really 1X plus 0.5X, so we're looking for 1.5X. So those of you who are algebraically inclined, if we plug the 20 in, we would do 1.5 times 20, and then this would give you 1.5 times 20 would give you 30. But let's just look logically what happens. $20 is the original price, and then he adds on 50% of the 20. So 50% of 20 is half of 20, which is 10. So this is really 20 plus 10. So just logically thinking about it, we get the same answer, 30. Now her commission is 10% of the sales price. So we're looking for 10% of 30. So again, just like in question 3, we could use a box method here, or we could convert 10% to a decimal, which is 0.1. We need to understand that most of the time of means multiply in math, so it's 0.1 times 30. And so this can also be written as 0.1 parentheses 30, and when we multiply these out, let's look at doing this. So we're doing 30 times by 0.1. Notice that we line them up against a wall. We do not line up the decimals with multiplication. Now we do one. We just treat them as though that decimal isn't even there. 1 times 0, 0. 1 times 3 is 3. 0 times 0 is 0. 0 times 3 is 0. But then we go back and watch what happens in green. The decimal point after this 30 is right there. So this is like 0 places over. But the decimal point here is 1 jump. So when we add these two numbers together, 0 plus 1, we get 1. So that means that we must put the point back in 1 place over. So our final answer for the commission that she makes is $3 because it's 3.0. So we should say, capital T, we should say the sales assistant, and writing your answer as a sentence really shows that you understand the question and what it's asking, and also it helps you spot mistakes. You might be writing the wrong answer here and realize it with your words, but the sales assistant earns $3 on a product originally costing $20. Okay, So that's our answer. And at this point we can think, does that seem reasonable? $3. She makes $3 if the store sells something that cost them $20 and they sell for $30. So $3 on a product that sells for $30. And it does seem reasonable. If we multiplied incorrectly and we got $30 here, how could that sales assistant earn $30 commission on selling something that only sells for $30? That wouldn't make sense, but $3 does make sense. Okay, that was question number 4. Question number 5. Okay, so Sarah is saving for a new car. It cost $12,000. So I'm going to write this down. Costs 12, 1, 2, 3. She already has $6,000 saved. So this just helps me get through types of questions like this, which just have so much wording around it, and it's really confusing. We might get lost very easily. So let's just bring out this information. Then we can forget the word problem itself. And she can also save an extra $250 per week. So $250 per week she can save, and that saves after she paid all of her bills. Okay, so the real question is, at least how many more weeks must she work to be able to afford the car? So let W, and really this is called defining a variable, let W equal the number of weeks. Okay? And this at least, I'm actually going to underline it in red as well, because this is super important. This, whenever you see at least, you've got to start thinking about inequalities. And in fact, this question gives us a big clue over here, where it tells us write an inequality to represent this situation. Solve it and then graph it. So let's think. This, now we go back to our key information here. Cost saved, $250 per week. This is, she can save $250 a week, and let W equal the number of weeks. So in looking at this problem, the grand total she needs is $12,000. What she has is $6,000, and what she will have is going to be $250 per week. So if it's 1 week, it would just be $250 times 1. If it's 2 weeks, $250 times 2. 3 weeks, $250 times 3. 4 weeks, $250 times 4, and so on. So we're multiplying by the number of weeks. So we're just going to put the W in there. $250 times W. Now, this at least, we need this amount on the left, to 6,000 plus $250W, to be at least. Now, at least means it can be more than, but it also could be equal to. And so at least tells us it's got to be more than or equal to. And this inequality sign is the more than or the greater than, but really it's the greater than or equal to, the more than or equal to sign. So we just did this first step, which is write an inequality. We now need to solve it, which means we're going to think about what is happening to the W and try and undo everything. So what we're going to do for this is we are going to think, well, 250W means 250 times W. So the W is being multiplied by 250, and then it's added with 6,000. So what we've got to do is subtract the 6,000. We're undoing everything by working backwards. If we do it here, we've got to do it to the other side. Subtract 6,000. Remember, we're lining these decimal points up when we're subtracting. And even if you can't see the decimals, they are there. 12,000 minus 6,000 gives us 0, 0, 0. 12 minus 6 is 6. 6,000. We bring down our inequality. These cancel, and we're left with the 250W. Now think again, what's happening to the W? Well, it's being multiplied by 250. So to undo that, we use the inverse operation. That's the fancy word, inverse operation, which is the opposite. So instead of timesing by 250, we're going to divide by 250. We've got to do the same to both sides. And then these cancel, and we are left with W is greater than or equal to. Now, I'm going to change color to orange. I'm going to try and figure this out. 6,000 divided by 250. If we had our calculator, we could go straight to it. We could just find the answer. But let's use our brains. We've got zeros on top and bottom. So and it's the trailing number, so we can actually cancel out 2 of these zeros. That's just dividing the top and the bottom by 10 each. Now 600 divided by 25, we could start by dividing by 5s and all of that stuff. But let's divide by 25. How many 25s go into 25? Well, 125. How many 25s go into 600? Now, because for Americans, 25 is a common number, it's a quarter, and 600, we can think of $6. We can think how many quarters go into, firstly, a dollar, into 100. Well, there's 4 25s in 100, so that's 4. Now, we've got 600. Not 100, but 600. So if there's 4 25s in 100, to find out how many 25s are in 600, we do the 4 times the 6. So we would do 4 times 6. And this gives us 24 over 1, which is, of course, just 24. So W must be greater than or equal to 24. This is the solution. This is us solving it. Notice I keep going back to this question to make sure I'm doing every single part. I wrote an inequality, I solved it, but I still need to graph it. So for graphing, I'm going to change to green. To graph this inequality, we would draw a straight line, or as straight as possible, with a ruler. I labeled 0. I'm labeling 24. And really, this is 24 weeks as well. Alright, so write an inequality, save it, so W must be greater than or equal to 24 weeks. Now, graphing it, after I've shown my number line, I now need to do a little bit of shading. So I'm going to grab blue for this. Now, W must be greater than or equal to 24, so it can't be 23, can't be 22, 20, can't be 0. Those are all numbers smaller than. It's got to be greater than or equal to 24, so I'm shading to the right. So notice I'm going to, on paper this is a little easier. As long as you're showing it shaded to the right, we're showing the solution set. I'm going to make this an arrow as well. We're showing it can be all the way to the right of 24. But can it be 24? And it can, because it has the greater than or equal. If it didn't have this line underneath the inequality, then it wouldn't be possible for it to be exactly 24. If that was the case, we would just do an empty circle. But because it can be equal to 24, we represent that by shading in this circle. And that's the end of this problem. We wrote the inequality, we solved it, and we graphed it. And just remember, graphing doesn't always mean an X and a Y axes and showing points or showing lines. Here we just graphed it on a number line by showing a shaded area on that number line and also a circle filled in on 24. That's our answer to number 5. Okay, question number 6. So in this case, we're told the cost of a new laptop with 9% sales tax included was $572.75. What was the cost before the sales tax? So let's think about this. A laptop cost before the sales tax, let's just call it X. This is the ticket price. Now, some countries, like the States, the price that you see on the shelf isn't always the price you pay, because when you get to the checkout, the cash register, they're going to add the sales tax on for you. Places like Britain, the price you see is always the price you pay. You don't even need to try and calculate this yourself. Okay, so in this case, it's an American situation, and so the 9%, the original price was X, that's the ticket price. Now when you add the 9%, and remember this is 9% of X, you get 572. 572.75. But what was the cost before the tax? They're trying to find the price of X. So, few ways to do this. Let's just do it algebraically for now. 9% of X, let's think. 9% as a decimal, if we divide by 100, 0.09 of X means times by X. So you just write 0.09X. The X stays, and remember this is almost, we can think of it as 1X plus this equals 572.75. Now we've got the same animals here. We've got X's, the same exponent. It's both hidden, but it's both an invisible 1. So really we can add 1X with 0.09x. And when we do that, we get 1.09x equals 572.75. So let's not take our eye off the ball here. Our mission was from the very start to find x. And right now, although they're decimals, we have a one-step equation, in which case we can find x. To undo it, we think what's happening to the x? Well, it's being multiplied by 1.09. So we undo it with an inverse operation. We do the opposite. We divide by 1.09. Do it to both sides. Dividing by 1.09. And in this case, this cancels. So we get x equals, now I'm going to jump on a calculator. I think that's reasonable right now. So we're doing 572.75, and we are dividing by 1.09. And in this case, we get a long decimal, and it goes 525.458, and so on, right? And this is just going to go on and on. Now, because it's money, we're going to need to do a little bit of rounding here. So money, we only go to 2 decimal places. Now, it seems like we should round this up because these 2 decimal places here, the last place that we're going to allow, which is the hundredths, is going to be affected by this 8. Because the 8 is more than 5, it pushes this up to a 6. Everything else stays the same. So in this case, our price before, our cost before adding the sales tax was 525.46. And really we should write this as a sentence to double check and to show whoever's grading it that we completely get this question. So we reuse the words that's in the question. So the cost before adding the sales tax was $525.46. Okay, and so just writing this helps us just put everything into context and think, is it reasonable? Well, it is. It's less than the price that he paid with the 9% added on. And it helps us reflect, and it shows that we understand. And, you know, this is one good way to finish questions, writing our answers more as in sentences. So that was question number 6. Number 7. So in number 7, we are told that we've got a circular table, and it's the circumference. So C equals 12 pi for this particular table. Okay, so here's my circle, and the circumference is 12 pi. And they want to find out what's the area. Area equals what? And that's what we're trying to find out. So first of all, we got to remember these things off by heart. We should know that the formulas are C equals 2 pi r, and the area formula is A equals pi r squared. So these are our 2 formulas. Now, one thing I'm noticing, let's switch this to green. One thing I'm noticing on this side, we're given a circumference. So instead of saying C equals 2 pi r, we know that C is really 12 pi feet. So let's just write that 12 pi, which is C, equals 2 pi r. So we're letting the value of C equal whatever the formula was. Now this looks a little weird because we've got numbers, we've got pi on both sides. And so we've got to think, what are we trying to even do here? We're trying to find the area. But to find the area, we're going to need to find out what the radius is. Over here, we're given information containing the radius, but we have to try and get to that value for the radius. So in this case, I see that the radius is being multiplied by 2 and then by pi. So what I can do is divide by 2 pi. This will cancel the pi's, cancel the 2's, and it will get straight to my answer for r, the radius. But if I do it to this side, I've got to do it to the other. Divide by 2 pi. The pi's cancel. And 12 divided by 2 is 6. So I just found out that the radius is 6, and the units we were given were feet, so it's 6 feet is the radius. So once we know that the radius here is 6 feet, we can plug this into our area formula. So A equals pi r, which is 6 squared. This equals pi times 36. And because in math and algebra we always put the number first, the coefficient first, so that's the same as 36 pi. And we should write the units, which we were given feet, but because it's area, it's feet squared. So again, we should get in the habit of going back and writing it as a sentence. So the question was, what is the area of the table? So you can say the area of the table is 36 pi feet squared. And we can only leave it like this because it says leave your answer in terms of pi, which means we can leave the pi in there. If it didn't say that and we got to 36 pi, we would then multiply 36 by either 3.14 if we're allowed to round, or by the pi button on our calculator, and it would then give us our answer without pi. Question number 8. So this is a probability question, and it's showing a sample space, so let's get into it. The question starts off, below is a sample space for rolling 2 6-sided die. So some dice have more than 6 sides. In this, most of them have 6 sides. It says that the notation being used is value on the first, value on the second. So this 1 1 is like throwing a 1 on the first die and a 1 on the second die. This one right here, 3 6, is like throwing a 3 on the first and a 6 on the second. Whereas if we went to 6 3, it's like throwing a 6 on the first and a 3 on the second. As you can see, there's 36 possible outcomes. We can check that because it's 6 numbers this way, 6 numbers up and down. 6 times 6 is 36. So it's 36 different things that can happen. What is the probability that the sum of the values on the 2 dice being rolled is greater than 9? So it's talking about the sum. Sometimes they might say product. Sometimes they might talk about the difference. So we've got to be very careful. We need to find out the sum of each of these 2 dice added together. So I'm going to go through quickly and we're going to start to discover a pattern. These 2 added, 1 and 1 is 2. 2 added 1 is 3. And then 4, 5, 6, 7. This is 3. So you might, if you're doing this along with me on your worksheet, you're going to start to see the pattern. And the pattern is to do with the diagonals. So along the diagonals, you are seeing that the 5 continues down the diagonal, the 4 continues, the 3 continues. Here on 6s, so we know that 6 is going to continue. The 7s will continue, as will the 8s. And so all of these numbers in red are the sums. We're just summing the 2 numbers. And so we have 10, 11, and 12. So I think I got everything here. Now let's go back to the question. Question's right here. What is the probability, so our notation is P, probability that the sum of the values on the 2 dice is greater than 9. So this is probability sum greater than 9. Notice how I've written all of these words in the last line in a very simple way. This is probability notation. P parentheses means probability of, and then I've got sum is greater than 9. Well, we've got to go back here and look for where the sum is greater than 9. The diagonals help us. Along this line, this is when the sum is 9. Did those count? Are those sums greater than 9? Well, they're not. Those are equal to 9, but they're not counted for us. So neither are the 8s or the 7s or the 6s. So what we need to do is to forget about everything on this side and only look at the numbers that are greater. So we're dealing with this 10, this 10, this 10. Those are greater than 9. This 11, and this 12. So we've got 1, 2, 3, 4, 5, 6. We've got 6 outcomes that work, that are greater than 9, out of a total of 36, which they told us, or we could count them all. This is our probability. Now we could simplify it. Divide by 6, divide by 6. 6 over 36 is really 1/6. So this is our answer. So again, you could write out, and you should write out the whole sentence. The probability that the sum of values on the 2 dice being rolled is greater than 9 is 1 out of 6. 1 over 6. And probabilities you can write as fractions, decimals, percents, but it's easy enough for us just to leave this as a fraction. In this question, we are told that Martin walked 2/3 of a mile. So I'm just setting this up. I kind of know what's coming, so I'm just putting a key here. 2/3 of a mile. He walked in 8/9 of an hour. Okay, so this is like a ratio. A ratio is a comparison of two amounts. So 2/3 of a mile gives us 8/9 of an hour, or really 8/9 of an hour allows this person, Martin, to walk 2/3 of a mile. So that, even though we got fraction over fraction, that's okay for now. And it says, what is his average walking speed? So when we're dealing with speed, often in a car, we're dealing with miles per hour. And this per hour is really talking about 1 hour. And often this can be written as mph, miles per hour. But when we're dealing with speed, we're talking about 1 hour, or you can have a speed per second, speed per millisecond, speed per week. But in this case, we're talking about hours. Hours are given to us. So we could set this up as 2/3 over 8/9 equals his speed, which is a number of miles per 1 hour. Now, we could cross multiply this and solve it as we would do with most proportions. But because this number here is 1, let's just think, what is x divided by 1? And x divided by 1 is just x. So instead of just cross multiplying, which would in fact give us an extra step to do here, we could just now do 2/3 divided, so let me write it this way, 2/3 divided by 8/9. And because we're dividing fractions, we can stick with the keep, change, flip KCF. So we keep the first, 2/3. We change the division to a multiply, and we flip the second fraction, which is 9/8. It's the reciprocal. And so 2 times 9 is 18. 3 times 8 is 24. So this is our value of x, but we can simplify. Okay, so in this case, we can actually divide by 6. We could divide by 2, we could divide by 3, but dividing by 6 gets us there quicker. 6 into 18 goes 3, 6 into 24 goes 4. So this is our value for x, which is the miles per hour. So in this case, we could write, let's change to red, his average walking speed is, and you could write it in both these ways, 3/4 miles per hour. And you could actually do miles/hour, or you could write mph, or you could also write 3/4 as 0.75 miles per hour. All right, so a couple of ways to do it. That was question number 9. Tens. This is the very last question in the first part of this 4-part series for the grade 7 math review. And so let's take a look. Describe each of the following probabilities with a word or a short phrase. So this is really about language. And 100%, if something has a 100% chance of happening, then it's a sure thing. So we could know 100% could be written in language or mentioned in language as a sure thing, as something being certain or a certainty. We could also think of it as something that's definitely going to happen. Now, 0% on the other hand is impossible. Okay, so for example, probability of rolling a number 7 on a 6-sided die. It's impossible. You're never going to do it. Okay, now in the middle of both of those is 50%. So you could call this 50-50. You could call it a half chance. If probability of rain is 50%, it means there's a half chance of rain. You could say it's equally likely. All right. Now I'm switching colors to go to 2%. Now 2%, some people might think is impossible, but it's not. It does. Out of every 100 times that it might happen, it's probably going to happen 2 times. So it's not impossible, but it is highly highly unlikely. Okay, and so 25% might be simply unlikely. 2% is highly unlikely. And so 80%, you could think of 80% as likely. Right? It's got quite a high chance of happening, but 96% is highly likely. And a few other words that really it's just good for us to know. Something that's possible, even though it's not asking us for this here, something that's possible means that the probability of it happening, whatever it is greater than 0. Okay? Greater than 0% if it's possible. So all of these from above 0, all of these right here are possible. Okay, whereas 0 is impossible. Okay, so this concludes the first part. These are the first 10 questions out of 40 for the 7th grade math review series.